You can't cure a disease without also curing the soul.
Interesting. What does that mean?
That means that the networks that control your brain are linked to the networks that are controlling the health of your organs. If the signal to turn off inflammation doesn't come, the inflammation can persist. Chronic stress, chronic anxiety is an inflammatory condition where the presence of inflammation gets worse, not better.
President of the Feinstein Institute for Medical Research.
The father of bioelectronic medicine.
Generations of people in the future will say, I was saved by the work that Dr. Kevin Tracy did.
We're living in an era where we can map the origin and the destination of all the nerves in the body. And with those maps, we will be able to design devices and someday even drugs that can target the individual fibers in an individual patient to give the treatment that that patient needs.
Specific without side effects, probably.
Right.
Wow.
This is happening. I worry that young people today, you talk about how much anxiety there is. I think a lot of that stems from the fact that young people today are not spending enough time developing a strong personal philosophy. Without that, it's just, I can't imagine getting through it. With that, you can do anything.
What is the #1 skill you wish every human being could learn to master to help them improve the quality of their life?
I think.
What is the biggest thing that's blocking people from creating harmony within their internal system? And also, the difference between the vagus nerve and the nervous system. So we can kind of start there and talk about some of this.
Well, first, let me say thanks for having me on. It's great to be here, and congratulations on all the success you have had and are having.
Thank you.
Your success is great.
Thank you, thank you. The great nerve and greatness, you know?
So the name The Great Nerve comes from the fascination that the world has had in this nerve for 2,000 years. Galen, arguably the first physician scientist in ancient Rome, used to call this the great nerve. So maybe we should start by what it is. So first of all,
what is the vagus nerve?
What is the vagus nerve? What is the great nerve? You have two of them, like two thumbs and two kidneys, one on each side. It
Coming down here.
Starts at about the level of your ear, runs down your neck, across your chest, into your abdomen, and it touches all the organs in your body that you don't think about all day long. All the organs that are operating when you're healthy in complete harmony, because their reflexes are being controlled by the brain and the vagus nerve to balance the function of all these organs. So why is it great? Because it's the only nerve in the body that if you cut it on both sides up high, you die.
Wow.
It's required for life. It's required for health.
What if you just cut one side?
Then
You
you're okay.
suffer.
The reason that the vagus nerve cut on both sides leads to death is because it's critically important in sending signals that coordinate the function of the heart and the lung. If you only cut one side, that you can accommodate that.
Interesting.
But it's not good.
Okay. So that's the vagus nerve.
Well,
And does
not
it connect to the brain and goes through the heart as well?
It runs, so that's the next important point. It runs from the brain to the body and back. So it's a two-way highway. In fact, 80% of the signals that travel in the vagus nerve go from the body to the brain. Only 20%, give or take, run from the brain back to the body.
Okay.
Now, the key to this, we keep talking about the vagus nerve, and I already said you have two, so it should be vagus nerves.
Okay.
On each side, you have 100,000 fibers. So it's much more proper, what we understand today, to say that you don't have a vagus nerve. You have 200,000 vagus nerves. And what we've learned, my colleagues and I, in the laboratory at the Feinstein Institute and now in dozens, if not hundreds of labs around the world, is we've learned that each and every one of these fibers, 200,000 fibers, has a job description. It has a beginning and an end, and the signals that it carries are incredibly specific. So some, you asked about the heart, some go to the heart. And the fibers that go from the brain to the heart tend to slow heart rate. Some go to the spleen and other organs of the immune system. And my colleagues and I discovered that the fibers that go to the immune system slow inflammation or inhibit it or stop it. Other fibers go to the pancreas to control insulin. Other fibers go to the intestines to control the processing of your food. So you don't have a vagus nerve, you have 200,000 vagus nerves. And when someone says to me, I want to do something to stimulate my vagus nerve, I say, oh, really, which one?
Right. Interesting.
And that's important.
And you've done, I mean, as a neurosurgeon, you were telling me you've done over 1,000 either brain surgeries or spinal cord surgeries over a decade of time. What was the greatest lesson you learned about the nervous system and how the brain and body connects or works in unison through all those surgeries you did?
That it's complicated. That's the main lesson. The main lesson I learned about how complicated it is rooted in the fact that when two neurons interact, let's go from 100 billion neurons in your brain and nervous system with trillions of connections. When you realize that each and every one of those neurons interacts reflexively. A signal into one neuron from another neuron means I'm going to do this. A signal in from a different neuron to that neuron means I'm going to do that. Well, one of the fathers of neuroscience explained it in the 19-teens very, very simply and in a way that can't be better explained. Charles Sherrington said, if you understand a simple reflex, so that's when the doctor
hits your knee.
The doctor hits your knee with a reflex hammer, your leg goes up, and you say, who did that? Basically what happens is there's a sensory activation, there's a sensory neuron into your spinal cord, and that activates one of these connections called the synapse, which sends signals back down through a motor neuron to the muscles in your quadriceps femoris, and your leg goes up. Sherrington said if you understand a simple reflex, then you realize if you put two reflexes together, or three, or four, or more, and on, till you get up to however many billions, you can assemble a nervous system. But the basis of what's happening is reflexive. The third thing he said, so you understand a reflex, you can build a nervous system, and the third thing he said was, there's no such thing as a simple reflex, because they are all connected. So that's what I learned is the most complicated thing. We, as researchers, as scientists, as doctors, we tend to reduce complicated things to simpler and simpler component parts, and you have to do that to figure out how things work. But at the end of the day, they're all connected.
Everything's connected.
Everything's connected. So the brain as the source of your mind, and your body as the part of your nervous system, is in fact all connected. Plato was right. You can't cure a disease without also curing the soul.
Interesting. What does that mean?
That means that the networks that control your brain and your mind are inextricably linked to the networks that are controlling the health of your organs.
Wow.
And back to where we started, the principal, I like to call it a transatlantic cable connecting the brain to the body and all its organs, is the vagus nerve. People call it a highway, but a highway is full of traffic and is messy. It's more of a transatlantic cable. And so you can imagine you've got the server in New York transmitting movies to wherever, Paris or London. And the submarine comes along and decides the submariners want to watch a movie. So they patch onto the cable and they listen in and they project the movie up on the wall and they watch whatever, Gone with the Wind. Now, some today in the billions of web impressions keep pointing at the vagus nerve and saying, as if the movie's in the vagus nerve. The movie's not in the vagus nerve. It's not in the cable. It's on the server in New York. The information is being transmitted through the transatlantic cable. So in this case...
Which is the vagus nerve.
Which is the vagus nerve. It's the great nerve.
And there's something you said about a quote from Plato. What was that quote again?
That you can't heal the body unless you also heal the soul.
So if someone is feeling some type of pain in their body or inflammation in their body or chronic illness that's been going on for a long time or whatever, something's going on, they have anxiety, depression, they have irritable bowel syndrome, they have something happening where it's like, how do I get through this? Eczema, some type of condition that they don't know where it's from. Am I hearing you say that when you can start to heal the soul or the mind that's connected to the soul, the thinking, the intention behind the soul, then you can create harmony within the body and heal the body? Is that what I'm hearing you say?
I think what Plato meant is that they're the same thing. And it depends. So let's break it down to like something, first principle, something. So pick one of the conditions you listed.
Let's call it like an eczema or something, or or inflammation in the body and the joints.
How about inflammation in the joints?
There you go.
Inflammation in the joints.
Like an arthritis or
like arthritis.
Yeah.
Inflammation in the joints can come on very noticeably with pain. Inflammation is pain, swelling, redness, heat. So that can come on and it can be quite noticeable. And the pain and the presence of inflammation activates all of that, activates sensory nerves to send signals into the brain. In a case of mild, say, inflammation of a joint because you jammed your finger catching a football, that inflammation is usually self-limited and self-resolving because the signals that go into the brain and through the autonomic nervous system activate signals that come back down to the body to slow down the inflammation when the joint is healed or healing. Now, let's imagine for a second, in that simplest of cases, that the wires going in or out aren't working properly for whatever reason. If the signal to turn off inflammation doesn't come, the inflammation can persist. And persisting inflammation now can cause damage to the tissues it originally started to protect. So that's the simplest of examples. And that's just right now focusing on the body. We haven't said anything about the mind. Now let's put the mind in place. The arrival of a pain signal in the brain activates reflexes to protect the body.
Yes.
Some of those, quote unquote, they're called stress reflexes or fight or flight or sympathetic reflexes, have significant benefit if you need to run away from an attacker, a lion or a bad guy. Then it's clearly beneficial to have the energy and to not be worried about the pain.
Yes.
Forget about it. That's what
So you're
happens.
flooding adrenaline into the body so you don't feel the pain for that period of time.
Right. The young woman who picks the car up off her injured child. You know?
Yeah.
So these signals coming back down acutely in large amounts will tend to dampen and slow down inflammation. Acute fight or flight inhibits inflammation.
Interesting.
But let's say the wires are broken again. Now the inflammation's not inhibited, okay, because the signal didn't get there. Now what do you have? Now you have pain day after day after day after day. Now you don't have massive fight or flight. Now you have chronic, low-grade activation of fight or flight. That's pro-inflammatory. So chronic stress, chronic anxiety actually is an inflammatory condition where the presence of inflammation gets worse, not better. So it's complicated.
Yeah.
But if you walk through it step by step, you can break down the components.
But doesn't the inflammation, I mean, obviously it's in the body, but what I'm hearing you say is that there's a strong connection to the way we think, the intention behind our thinking, the emphasis of the quality of our thinking that is influencing, I guess, the electricity to send or not send or flow or not flow, whatever it needs to actually heal, or am I off there?
No, you're not off, but you're correctly paraphrasing what billions and billions of web impressions and web recommendations say.
Really?
Absolutely. So many of these things are being repeated over and over like mantras. When you break down to what are the reflexes, what are the neural circuits that underlie this that we can put under conscious control, you kind of run up against a wall very quickly. What is it you can consciously control? You can consciously control your breath rate. You can slow down your breathing, if it's not you can't always, but
Right.
In this example, you can slow down your breathing. Have you just stimulated your vagus nerve? Well, maybe, right?
Maybe you calmed it.
Well,
Right.
you
or
haven't really calmed your vagus nerve. You've calmed your mind.
which impacts your vagus nerve.
Yeah, it impacts maybe a few hundred fibers of the 200,000.
Okay. Okay.
We're back to like, what is it we really understand? And do we know that slowing breathing one way, let's say in on 3, out on 7, or box breathing, 4, 4, 4, in on 4, hold 4, out 4, hold 4. These are all, and how many techniques are there?
Tons.
Hundreds, dozens,
Yes.
hundreds. Do we know what each of those methods does to the vagus nerve? No.
No. It might
don't.
help us feel better in that moment. It might help us calm
Great.
our mind. Yeah.
Great. Here's what we do know. If, in general, these activities, and we can go through them one by one, but the cognitive behavioral therapy, prayer, some breathing modalities, not others, because what I'm going to say will make sense.
Cold exposure.
Not cold exposure. And we could talk about that. That's complicated. But let's do just relaxation, meditation.
Yeah.
That's
Yes.
what I couldn't think of. So you've got these states where you induce relaxation. They almost always slow heart rate. If your heart rate slows from something you did, then you did arguably stimulate the fibers in your vagus nerve that go to your heart, because that's what it does. But you may have also inhibited the fibers in your sympathetic nervous system that accelerate your heart rate.
Right.
Which did you do? Nobody knows.
Interesting.
You don't know, nobody knows.
Interesting.
So you talked about the book. I wrote this book not to say that these things that are being promoted, some with all good intention and some less so, these things that are being promoted, many of them are grounded in some basic science facts. But to extrapolate it further than that, first of all, it's no way to be proven true or false. But second of all, it puts, in the case of a patient with an illness, it runs the dangerous risk of putting the blame on the patient. Let's go back to the example I gave before. If you have an infection that damaged your vagus nerve, and you have arthritis, and you go online and someone tells you to do 10 extra push-ups because that'll stimulate your vagus nerve and stop your inflammation. No, it might not for you. So I as a physician scientist, never want to be in the situation where we say, we know this to be true, therefore it will work in you.
Right.
That's not always the case.
It may or may not work. You have to try it out.
It
and
may
test
or may not work at all. It may or may not work in you. It may or may not work in somebody else. So how do we get past that in the modern era with all of our powerful tools? We did discover that you can put a computer chip on the vagus nerve of people with severe inflammation from rheumatoid arthritis, and that can make many of them better.
Really?
Yeah. And that's based on 28 years of work in the lab, first in my lab and now in literally dozens, as I said before, hundreds of labs around the world. And what we discovered are, of the probably 100,000 vagus nerve fibers on the left side of people, of humans, several hundred, maybe 1,000 of them travel down into the area of your spleen and your abdomen, which is one of the major organs of the immune system. And when these signals arrive there, and we can activate the signals with this little computer chip, these signals arriving in the spleen are a calm down signal to the white blood cells that pass through the spleen. So the spleen gets 20% of your cardiac output every minute. That means a huge percentage of your circulating white blood cells go through that spleen every hour. If the vagus nerve signal is sending a calm down signal to the cells that are passing through the spleen, they get pacified. They get calmed down. Now when they arrive at that injured finger, they don't attack what they see. They actually switch into a more tissue reparative mode. So it's as if rather than a soldier arriving at the front and shooting, it's a team of medics that come and start patching things up.
Interesting. That's what you want.
That's what you want, and that's what we know that works if you directly stimulate the vagus nerve with a chip. There are patients with very famous, widely publicized stories. There are stories of people, as you say, who were unable to walk up a flight of stairs and are now riding their bicycle several miles every weekend.
Can you send some of these case studies or visuals, if there's any after this, and we can put some in to show people or link them up?
The visual I would send you is in my office.
Okay.
I met a patient named Kelly, who was one of the first patients implanted in a study that we did in Europe years ago. And Kelly was one of these patients who couldn't walk up a flight of stairs. She was told by her physicians that she had to retire as a teacher. And she and her husband, Sean, were out of options. They had been nearly bankrupted by the expense of her drugs that weren't working. They sold everything they owned. Kelly talked her way into the clinical trial in Europe. She moved to Amsterdam.
Wow. How old was she when she did this?
Not sure exactly. Late 20s, early 30s.
She's young.
Yep.
Very young.
Yeah.
Wow.
Yeah,
Was it
yeah.
arthritis or was it like inflammation in her feet or?
It was actually inflammatory bowel disease, but a complication of Crohn's disease that she had affected her joints. Mm-hmm. To the point that her father, for one of her birthdays, gave her a cane.
Oh man.
Because she was in and out of wheelchairs.
Oh.
So
in her 20s. Yeah.
Yeah. So Kelly and Sean moved to Holland. Kelly received one of the first, I call it a Gen 1 implant. It wasn't the small chip we have today. And she had to stay there for a few months afterwards for her follow-up checks. And they were running late to the doctor's appointment. And there was an elevated train, and Kelly saw it coming. And this is a few weeks or a month post-op, and she ran up the stairs.
No way.
And she's about to get on the train. She realizes Sean's not with her, so she stops. And she looks at Sean like, what the heck? And Sean's at the bottom of the stairs crying.
Oh my gosh.
Because he couldn't remember when she did it.
Oh wow.
Gets better. I didn't know any of this till I got an email. And I invited Kelly to, I'd never met her, didn't know who she was. She came to see me. And she gave me a gift. And it's in my office. It's her cane.
Oh my gosh. Wow, that's powerful.
I left the bow on it. I have a picture I can get to that.
Oh, that's beautiful. Wow, man. How old is she now? When was how long was it?
She's in her 30s. She is now restoring guitars. Tell your listeners to look up Kelly Owens Guitar Restoration in Connecticut. She
She
worked
lives in Connecticut?
Yes.
Wow.
She worked for us at the Feinstein Institute for several years after that. She was a patient advocate that helped us collect the hundreds, ultimately more than 1,000 emails we were getting for patients that want to participate in these kinds of things. And she retired from that to move on.
Make guitars.
To restore old guitars. Yeah, and other artists.
And what is her, I mean, I guess.
And her husband's an amazingly skilled carpenter and woodworker. Yeah.
So was this 5-10 years ago, or when was this like?
The trial she was in was in the mid 20-teens. So,
Okay.
So she's now
10 years ago, right?
Yeah. The last time I looked, I think she's 8 years out. She takes no medications.
And she can walk upstairs. She can use her hands fine. I mean, maybe there's
She
still
goes to the gym and works out on the treadmill.
Come on. Does she have pain anywhere today, or is it like minimal
I haven't
pain?
talked to her recently. I'm sure as we all get older, we all get some aches and pains.
Of course, yeah. But that's
But no.
interesting. But she's able to move, walk, and do all these
Yes.
things, and
Yes.
pretty normal lifestyle then.
Yes.
All from one little implant, or
Yes.
maybe that one was bigger, but
It was bigger.
All from an implant
Yeah.
here.
That one I call Gen 1. It's like a cardiac pacemaker, and it goes under the collarbone.
Okay.
And then a lead goes up to the vagus nerve in the neck.
Interesting.
That device has been put in at least 250,000 people
Really?
to treat. We come back to the mind again at some point to treat depression and epilepsy.
Interesting.
And it's been FDA approved in the United States for decades. And we know the complication rate. We know that it's quite safe. We know that at least 250,000 people have been studied. I estimate that somewhere over 500,000, maybe 1 million people have had this surgery worldwide. This is with the large device that fires on for 5 minutes, off for 5 minutes, 24 hours a day at a 10 times higher amount of current than we use in this little chip. So when people look at the side effects of vagus nerve stimulation for depression and epilepsy, they're going to see things like twitching of the lip, buzzing in the vocal cords when they speak. And of course, with any surgery, you can have a very small risk of a wound infection or potentially damage to the nerve. But when you look at the side effects of the small chip that was put now in 242 people in the United States in the last couple of years, the side effect, the severe adverse event rate, it's called, was 8 times less than the severe adverse event rate of the drugs.
Interesting. Of the drugs, yeah.
The drugs, which are also invasive and have to be injected.
Yeah, painful, yeah. So if someone's had chronic arthritis for years and it only seems like it's getting worse, is that a soul healing or is that a vagus nerve healing and total body healing? And it sounds like no drugs can really heal something like this. Maybe they can help some people sometimes, but it doesn't seem like there's a drug that can help reverse arthritis or certain conditions.
So let's talk about, again, rheumatoid arthritis, which is one type of arthritis, and what we know and what we don't know. We know that rheumatoid arthritis is a very common condition. It affects up to perhaps 1% of the population or 1.5% of the population worldwide. It's very common. It tends to affect younger people, more women than men, and it's not sort of like the old football injury, my knee gets sore when it rains. This is a serious illness that affects all the joints, and many of these patients can't pick up a pencil, can't ride their bike, can't sometimes button their shirt.
Yeah.
And we also know that we have powerful drugs that have treated very well many of these patients. These drugs go by the names of DMARDs for disease modifying antirheumatic drugs, or biologics, which are typically antibodies. You see them advertised on the nightly news. You see them advertised on all the sports on TV. These are very powerful drugs. They work not because they cure inflammation, but because they suppress the immune system.
But do you want to suppress your immune system?
You don't want to suppress it too much.
Yeah.
If you suppress your immune system too much, you leave yourself open to secondary infections, even to cancer. So many of these drugs that are
side effects of those then.
Many of these drugs, the side effects have the most serious label that the FDA can give, which is called a black box warning. And many patients, even though, let's be clear, millions of patients have benefited from these drugs. Millions of patients have benefited from these drugs. But many patients, despite the benefit, don't want to take them.
Yeah.
Many of them have to be injected, so they're invasive. Many of them cost between $30,000 and $100,000 annually.
Oh my goodness.
Many, if not all of them, have dangerous side effects, and so people are reasonably concerned.
There's no guarantees for healing, and it's like you have to stay on these things forever, it sounds like.
Not only is there no guarantees, but in most studies, these drugs are effective about half the time. So despite the fact they're invasive, have side effects, and are expensive, they work half the time.
It may not work, yeah.
So what's the point of all this?
Yeah.
The point is, yes, some people are benefited, they don't need anything, and that's wonderful. But a lot of people want other options. And what this vagus nerve stimulation, which by the time this airs, may be approved by the FDA in the United States. If not, hopefully it'll be approved in the coming months after this airs. What that will allow is patients who have tried these other therapies, but as you said, are not getting better in their body or their mind, that they now will have an option of having an implant. The implant will be put in, it's about the size of a fish oil pill. It'll be put in through about a 1 inch or 1.5 inch incision in the neck by a neurosurgeon, right about the level of your Adam's apple, down deep where you feel the pulse in your neck. You won't be able to see it, and it will operate for about 1 minute a day.
Wow.
And many of the patients, I've met many of them, many of the patients sleep through the therapy at 4:30 in the morning or something like that. Other patients told me that it's like a little alarm clock for them, but when it goes off, they smile because they realize immediately their hands don't hurt anymore.
Really?
Yeah.
So it's a little chip that they implant.
Other side.
Left side, right? Left
Yeah,
side. This is where the
left
pulse is, right?
Yeah,
That you feel
yeah.
here on the left side. Next to the pulse. And you've had over 200 and some people already go through this in the last year.
So exactly. So the company's called SetPoint Medical. It's not far from here in Valencia, and they completed a clinical trial last year. They reported the results.
And these are people that were having extreme pains, like for years.
All of these people were out of options. They had
They tried the drugs, they've meditated for years, they've prayed, they've done everything they can, and they're just feeling pain.
Yep, pain, stiffness, swelling, and many of them had symptoms of in their mind of either anxiety, depression, sleep disorder, cognitive abnormalities. And what the results showed is not only did a significant percentage, a statistically significant percentage of the patients with the implant have improved pain and swelling in their joints, many of them also had improved quality of life. Less anxiety, less pain, better sleep, less depression.
And it doesn't require taking any drugs or invasive therapies, except for one invasion, I guess, of putting something in your neck. But
So that's going to remain to be seen. Many of the patients were able, after the chip was implanted, to reduce the drugs they were taking, but many of the patients continued to stay on some of the drugs. It's been 242 patients. There are millions of patients that will be eligible for this worldwide. It will take years to have a clear, simple answer to what you said. What patients will be able to take fewer drugs? What patients will have to continue taking drugs? What patients will have no response to this? And what patients will live their life not taking any drugs anymore?
Wow.
How those numbers shake out has to be studied in much larger populations. But I've met some patients who were taking several drugs and are now taking none.
really?
Yes, and having no symptoms.
What has been the biggest thing you've seen over the last 3+ decades of research, hands-on experience, and the science that you've been studying? What's been the biggest breakthrough you've seen in the last 3+ decades of just healing the body or body optimization?
I think the biggest breakthroughs I'm seeing today are actually coming from understanding the linkages between the brain, the nervous system, and the immune system. The vagus nerve insight, which we started 25, 30 years ago, was just the tip of the iceberg. Right now, the field, which is called neuroimmunology, is probably one of the fastest growing, if not the most exciting, fields in all of science.
Wow.
Young people want to study this because the tools are so powerful. In just again, in the vagus nerve story, we can go in a laboratory mouse and we can put tags in the neurons of the brains of those mice, and we can shine a laser beam on a discrete part of the mouse's brain and activate a few hundred neurons in the brain and follow the signals down into the spleen. And we can look at the molecules all along the way. We can look at the electrical signals. We can look at the individual steps. Those kinds of experiments are now being applied to all kinds of conditions, ranging from not only autoimmune disease, but diabetes,
Wow.
metabolic syndrome, and obesity. We're seeing studies looking at understanding how things like GLP-1, Ozempics, how these things work. These things are now all being broken down to signals traveling in individual neurons, not only in the vagus nerve, but in the sympathetic nervous system and in the neurons in the brain itself. We're living in an era where we can map the starting point, the origin and the destination, the origin and insertion of all the nerves in the body. First in mice, then in larger animals, and ultimately in humans. And with those maps, we will be able to design devices and someday even drugs, and perhaps nanobots, that can target the individual fibers in an individual patient to give the treatment that patient needs.
Specific, without side effects,
Right.
probably. Just to that thing. Wow.
That's where the world is headed. Is it going to get there tomorrow? No. Is this some pie in the sky, everyone's going to have a flying car 100 years from now? No. This is happening. Some of the things I said are already in clinical development.
Wow. Now, even though you're not a psychiatrist, have you seen any research on how trauma impacts the brain, whether it be psychological or emotional or sexual trauma, how it impacts the brain, the body, and the nervous system, and how we could stimulate the vagus nerve to actually start healing that trauma?
So it's complicated. At the simplest level, if we have seen now, if there's trauma in the vagus nerve or damage or injury, that you can have problems in the body because signals traveling in the vagus nerve are not getting where they need to go.
It's blocked somewhere.
Yeah, it's like, imagine going down a mountain and the brakes in your car, someone cuts the brake line in your car.
That's happened to me before. I mean, it didn't cut, like someone didn't cut them, but I was in an old Cadillac, a 1997 Cadillac, going up a mountain to Big Bear in California. And on the way down, the brakes gave out. And this is like an old car where it's like pumping the brakes. And there was a guy next to me I was driving. And I was like, we're gonna die. I was like, it's not braking. And I just shifted it down into like first gear or whatever and slowed it down. And it came back a little bit around these curves going down. And luckily got to the bottom of the hill, but it was scary.
You're lucky to be here.
It was scary, but it was like, this was probably 12 years ago, but it was terrifying. So imagine that in your body all day long, like the brake's not working and your vagus nerve is experiencing that.
It's probably what these people with rheumatoid arthritis felt like.
Interesting.
The brakes have failed. They have excessive inflammation in their body. The inflammation in their body is changing the way their mind is working and how they feel and their level of anxiety all day long, day after day, year after year.
It's exhausting.
It's exhausting. So that effect we understand. You asked about similar things in the brain. That gets complicated and is an area of active research, but it has come together very recently in studies of post-traumatic stress disorder. So post-traumatic stress is an example. A warfighter sees a horrible, or sees or feels some horrible scene and continues to relive it and relive that horrible event day after day after day, even in the safety of their home, here in California or somewhere else. A very recent study, they implanted vagus nerve stimulators in those subjects and timed the activation of the nerve, now focused on sending signals up into the brain, not down to the immune system. They timed the signals so that the therapy being given either by an app or by a human therapist, which is reasonably successful therapy. I'm sorry, I forget what it's called. Again, I'm not a psychiatrist. But this therapeutic modality has been reasonably successful and maybe helps half or 2/3 of the subjects with post-traumatic stress, which is pretty good, but not 100%. When they added the vagus nerve stimulation to the clinical trial, they had a 100% response rate.
What does that mean?
Well, what happens when you stimulate the vagus nerve, and we're back to the mind-body connection again, signals presumably going up into the brain increase neuroplasticity. What is neuroplasticity? Neuroplasticity is the ability for those connections that we talked about in the very first minutes of the podcast, which are called synapses. Neuroplasticity means that the brain can form new synapses. When you learn something, you form new synapses. When you unlearn something, you form new synapses. By driving these signals up the vagus nerve, increasing neuroplasticity, these post-traumatic stress patients, many of them had significant benefit from their therapy, and it is lasting.
It's almost like they have to unlearn the memory.
Absolutely. That's what the point of the therapy is.
Because the memory, if you're reliving it 5 times a day, it's almost like your body's in that trauma now.
It's a new experience when you live a memory again.
Isn't that interesting?
Trial lawyers have known this for decades.
And so you could be living in a war that you went through 10 years ago, but your brain is reliving it, rethinking it fresh. And so you're in that heightened state. It's going to be chronic illness, right?
Absolutely.
And so it's really more about, is it about eliminating the memory, changing the memory, reinterpreting the memory and creating meaning behind that memory so there's a benefit to it? Like, even though you're not a psychiatrist, what is that process so we can actually heal the mind, the thinking of the mind that's causing the stress in the body?
Yeah, I think psychiatrists, psychologists, and philosophers are talking about this now and trying to figure out the answer to that. You know, how much is unlearning, how much is relearning, how much is adapting. But at the level of the synapse, which Charles Sherrington taught us, if you understand the synapse, you can assemble an entire nervous system, even with 100 billion neurons. At the level of the synapse, vagus nerve stimulation enhances neuroplasticity. I mean, this has been known for decades. Years ago, there was a fascinating study. Patients who had an implant for their epilepsy. So in these cases, these are people with serious disorders, with seizures, epileptic seizures, that are not well controlled by medications. And some of these subjects were having 10, 20, 30 seizures a day.
Oh my gosh.
You can't go out of their house.
That's exhausting.
So as a attempt to treat that, vagus nerve stimulators were implanted in some of these subjects, and about half of them had significant benefit. Now you say at first, well, half's not a lot. Well, it's a lot if you're having 30, if you're one of the people having 30 seizures a day and you go down to having 2 or none or 3.
It's life-changing.
Life-changing. So during the course of those experiments, those clinical trials, some subjects didn't get significant benefit, so they had their device turned off, but they left it in. So researchers called them in for a clinical experiment, and they gave them a cognitive test, and they wrote down the answers, and then they turned the device on, and they gave the test again, and their scores went up.
Interesting.
That was one of the early signs of the fact that vagus nerve stimulation can improve cognitive function through enhancing neuroplasticity. It's very interesting.
Wow.
That's now been FDA approved for the treatment of rehabilitation, increasing rehabilitation in patients who've had a stroke affecting the arm.
Wow.
So what's done is the therapist does their therapy, but the delivery of the therapy is timed with giving vagus nerve stimulation through the left neck through a surgical implant. And for patients who've had paralysis of the hands and arms, the disabling thing is not being able to use the hands to feed themselves, hold a newspaper, hold a book. And the results from adding vagus nerve stimulation to that are absolutely remarkable.
Really, where people were paralyzed in an arm or a hand?
And are significantly better with their rehabilitation combined with the vagus nerve stimulation.
Maybe it's not full range and function, but
No,
it's like improved and...
Exactly. It's not necessarily full range of function, but it's significantly improved enough that the FDA has approved it, and
Wow.
It's coming in.
I mean, for me, I'm all about trying to find holistic solutions to heal the mind and the body. That's what I want for myself, the people in my life, the people watching or listening around the world, is there are people that have so many different either conditions, pains, stresses, overwhelms. And I think a lot of these things stem from the way people think and how they respond to their environment that impacts the fight or flight, tension, tightness in the body, which causes inflammation, pains, things like that, which then could cause into irritable bowel syndrome or eczema or whatever it might be. And my whole vision is to bring harmony and healing to humanity so they have the tools to do this for themselves and the people that they love. Because I think when people heal themselves and they heal their families, the world is healed. It's like there is so much more harmony in the world. There's less anger, resentment, wars, fighting, competition. There's more collaboration and more community. And that's my entire mission, is to bring people like you who have the decades of research, the knowledge, the literal hands-on surgical knowledge and the research and the data. And so I'm curious, how can we, going back to the soul, how can we learn how to heal the soul with the different therapies, strategies, and techniques that you've learned as a neurosurgeon?
I think you said it best, one person at a time. So everybody's different. And I think we can approach this with realistic optimism. Okay? Again, a first principle approach, the vagus nerve is transmitting reflexes. When those reflexes are functioning optimally,
Yes.
you have a harmonious function of the organs in your body in a healthy state with your brain
Yeah.
in a healthy state.
And we want brain, heart, organ coherence, is what I'm hearing you say.
100%. So
So we need the coherence of just a smooth, flowing machine, right, throughout all three systems, I guess.
what emerges from that coherence in all three systems is an emergent property. You can't predict plucking one string on a violin what the whole symphony will sound like. But the one string on a violin gone bad can make the whole orchestra sound terrible.
Right.
That's what the vagus nerve is like.
Interesting.
It's like one of the 200,000 vagus nerves.
Yes, yes.
Is like 200,000 violin strings. It's the difference between playing the piano, if the piano had 200,000 keys, and sitting on it.
Right.
So that's the role of the vagus nerve. Now, that's a fact. But let's not get carried away. Let's not say that the vagus nerve is the answer to solving all those things. It's a violin string. It has a part. If it goes bad, it can affect all those things. So what do we want to do with our interventions is we want to do our best to help keep the violin in tune.
In tune. Yeah, yeah.
Now you can do that. It gets complicated quick, right? It gets complicated quick. You can do that by making sure you have the best conductor.
Yourself, your mind, I guess.
Well, way up there, your
Yeah, yeah.
mind.
Your mind.
Your mind. And you can do that by making sure you keep the instrument in tune,
Yes.
which would be the level between your mind and the violin strings. It would be the middle of your brain where your emotional brain, okay? Which if it gets all fired up, it's going to put everything out of tune. So once again, I just don't want to rush into any answer
Yes.
and say, well, if the conductor has a heart attack, the orchestra's going to go out of tune.
Exactly.
If anxiety or some other emotional anxiety, fatigue, hunger, dominates, cranks the key too hard on the top of the violin, you're out of tune.
Yeah.
If you've got damage in the vagus nerve from an infection or an injury, broken violin string, you're out of tune.
Yeah.
And at the other end, don't forget the body. If you got that inflamed finger again, which is now pulling on the other end of the violin string, you're out of tune.
Yes.
So which one do you want to talk about first?
It's all got to work in unison.
It has to all work in unison. And I get the reason I spend so much time on this in this book is because there's so many quick fixes on the internet. And they're all, not all, many of them are rooted in one of those things.
But you need all of them, all those things to be working together. Yeah.
Maybe in you and me, 3 out of 4 are working right now. We only need to worry about one of them, but we don't know which one.
So how do you become self-aware on which one is off? How do you know what's out of tune?
Well, I don't. I mean, obviously, if you're feeling stressed and anxious, you could start with that first.
Yes. What would you say then is if someone is living in fear throughout their mind constantly, they just have fearful thoughts at work or in their relationship or their home or whatever it might be, or they're watching too much chaotic news and they're just living in fear and stress, or they're overwhelmed constantly, or they're just feeling like these heightened, stressful thoughts and emotions. How much is that impacting the vagus nerve and the nervous system and blocking us from feeling in harmony with our total body health?
A lot.
Really?
A lot. Yeah, no, the evidence for that is clear. So first of all, I'm not a psychiatrist. I'm not a therapist. I'm not recommending any sort of therapy for someone who has that much fear and anxiety in life. Should be talking to someone. Second,
because it impacts the body in a big way, the nervous system and the vagus nerve.
Absolutely. What we know is patients who experience that kind of emotional or mental anxiety, fear, and stress tend to have increased heart rates and decreased heart rate variability. Now, those patients tend to have increased heart rate and increased heart rate variability. Heart rate and heart rate variability are under the control of the autonomic nervous system. Heart rate is slowed when the vagus nerve is active, and it's sped up when the sympathetic nervous system is relatively more active. That variability in speeding up and slowing down is measured by heart rate variability, which many people now, millions of people, are looking at all the time on their wearables. Heart rate variability is very complicated.
Where do we want our heart rate to be at most of the time?
In general, we know from the Framingham study, which looked at thousands of people, and an even much larger study out of France. In general, you want a lower heart rate at rest rather than a faster heart rate.
At rest.
At rest. At rest, what we know from these huge population studies is that populations with a slower heart rate tend to live longer than populations with a faster heart rate. Now, before all your listeners run and check their pulse and say, oh, my pulse is 80, it doesn't mean that they're going to have a short lifespan, because you can't take a population statistic and apply it to an individual. If you could do that, you would buy the right lottery ticket. Okay, statistics from a population cannot be reduced to a single individual. But it's still very interesting that at a population level, slower heart rates, meaning more vagus nerve activity relative to fight or flight, tend to live longer than those with faster heart rates. Why is that? Well, no one knows. One possibility, it's because if you have a slower heart rate, you tend to have a healthier vagus nerve function that may also be slowing inflammation. We don't know. There's 200,000 fibers. It could be that the fibers to your heart are working fine and the fibers working to your immune system are not. But that kind of logic leads people to hope that if they can slow their heart rate through healthy habits, like regular aerobic exercise, eating a balanced diet, getting enough sleep, all the things your grandmother and your doctor tell you to do. Avoid too much anxiety and stress. Meditate if you have a lot of anxiety and stress.
Meditation.
Prayer, cognitive behavioral therapy. All of these things slow your heart rate. Isn't that interesting?
Yeah. It's good tools.
If
you use them.
If your doctor says it's okay, those are all safe, good tools in most patients. And if you use them, and if it slows your heart rate, you're probably doing a good thing for your body. You ask me what I do those things.
Yeah. Interesting. And so what's the difference between the vagus nerves system and the nervous system?
The vagus nerve is part of the nervous system.
Okay.
So one way to think of the nervous system is that you have a brain and a spinal cord. The spinal cord, of course, runs down from the base of the brain in the back through your spine. And it's principally involved in coordinating all the muscles that you can put under voluntary control. When you want to throw a basketball, hit a golf ball, sign your name, button your shirt, this is the voluntary nervous system.
Because when you think something, it's connecting, I guess, the wiring throughout your body to move. Like my hand movements right now, it's all just automatically connecting it, correct?
When you think, nerves in your brain generate the thought and the intention, and because that's what a thought is. It originates in nerves, and those nerves are connected to the voluntary nervous system, which sends signals down your spinal cord to control your muscles under voluntary control.
But if something is not being transmuted smoothly, you're saying it's not necessarily the cable or the nerve, it's the network.
It could be either or both. And that goes back to your first question. So if you think for a minute about, one example would be what happened with COVID. We know from COVID that many of the patients that died, and this is work out of Spain, towards the end of the pandemic, pathologists and researchers looked at the vagus nerves of people who died from COVID, and they found two things. They found inflammation and damage to the vagus nerve, and they found virus in the vagus nerve. Now, knowing what we know today, that signals in the vagus nerve are like the brakes on your car that suppress inflammation, and knowing that the signals that travel up and down the vagus nerve are critically important in controlling heart rate and blood pressure and breathing, part of the autonomic nervous system, which we haven't gotten to yet. Those are two of the major complications that occur in long COVID or in post-COVID syndromes. So we don't have the answers yet. These are real interesting scientific questions that did damage or does damage to the vagus nerve, contribute to or even cause long COVID, which is characterized by excessive inflammation and malfunction or dysfunction of the autonomic nervous system.
And what is the autonomic nervous system?
Okay, so we talked about the voluntary nervous system. The autonomic, as in autonomy, is the involuntary nervous system. And it's the part of your nervous system that, first of all, you never think about it, but it's controlling your kidneys and your intestines and your heart and your lungs and your pancreas right now, all day long, every second, every day of your life. The signals from, say, glucose levels in your liver are going up the vagus nerve, the sensory vagus nerve, into your brain. The autonomic part of your brain, the autonomic nervous system, receives that input and says, oh, this guy needs a little squirt of insulin now, or a little squirt of glucagon if your glucose levels are low. Those signals come back down, some of them in the vagus nerve, which is the parasympathetic part of your autonomic nervous system.
Okay.
And some of the signals come down your sympathetic nerves, which is the other part of the autonomic. So the autonomic has sympathetic and parasympathetic, but they work together.
Got it. Okay. I need to go back to science class, biology and science. Yeah.
It's not that bad if you,
I know.
if you put it in the context of this stuff
For
you're
sure.
interested in.
Exactly. It's fascinating to me. Now, as someone who's done over 1,000 brain and spinal surgeries, I guess of the ones that weren't through some type of force or impact, where you had to repair something like a car crash or some type of injury in that way, more of just, oh, there's a tumor or there's something off with the spine. How much of those, in your either scientific research or personal opinion, how much of that is caused by someone's lifestyle, someone's thinking, someone's mindset of those tumors, spinal issues occurring?
There's no evidence that brain tumors or cancer are caused by mindset. There's no evidence of that.
But in your personal opinion, do you feel like there could be?
I don't think so. No, I don't
just
think.
Chance. It's just like, oh, there's something off in the system, and it's just, oh, that just.
Well, I think there's a lot of evidence that cancer originates from genetic mutations in DNA of replicating cells.
Okay.
That now just keep growing when they're not supposed to grow. And
But where does that come from? Is that
well, it can come from a beam of ionizing radiation from outer space that hits you in the head.
Really?
Absolutely. It can come from some exposure to something in the environment when you were 2 years old. It can
Interesting.
it's a whole field of its own, and I'm not an expert in that field. However, it's pretty clear that the origin of cancer has a basis in genetic changes.
Interesting.
And that doesn't mean inherited. It can be, but it doesn't mean it is. So that it's not. There's no evidence it's from the activity of the nervous system. What's really interesting is that there are some new therapies that are used to now treat brain cancer, that are treating the cancer by putting in modulating electric fields that actually slow the replication of the cancer cells.
Really?
And so there you have another example of a bioelectronic medicine, which is what we call putting the chip on the vagus nerve in the neck, because we're using electronics to treat the nervous system. Here you see this is possible in some patients with brain cancer.
Interesting. How influential is the nervous system versus the immune system within the body?
They're the same thing.
It's the same thing. The nervous system and the immune system is the same thing.
They talk to each other. They use the same molecules. So for years, I joke about this a lot, but back when I went to medical school and in the several decades since, when the immunology professor was giving a lecture, she would tell the neuroscience students they could take the day off And when the neuroscience professor was giving a lecture, vice versa, he would tell the immunology students they could go home. Why is that? Because there's a blood-brain barrier which separates and filters things that can travel through the bloodstream to get into the brain. And it's like a firewall. Now, the immune system for centuries was thought of as white blood cells, which float around and are not attached to nerves. And the nervous system, of course, is about nerves. So, okay, two separate things, nothing to do with it. Well, it turns out that white blood cells in the spleen, in the liver, and many other organs come in contact on a regular basis with nerve endings.
Right.
What happens there? Well, white blood cells, it turns out, have receptors, meaning they can respond to neurotransmitters, which are made by nerves.
Okay.
Oh, by the way, it turns out nerves can make molecules like cytokines, like cytokine storm from COVID, things like TNF and IL-1 and IL-6, those were thought to be only made by immune cells. So they're using the same molecules to send signals back and forth, nerve to white blood cell to white blood cell, white blood cell to nerve. You tell me where to draw the line in two separate systems.
Right.
By the way, the nervous system makes memories. So does the immune system. Those, you talk about muscle memory when you train and train and train and train, and you can do something like without thinking about it. That's actually in your nervous system. The nervous system makes memories. You get exposed to a virus or an infection the first time, and chaos breaks loose, and in the defense, you have massive amounts of inflammation. The second time, the immune system, not so much, because it's made a memory of that attack. So that's the hottest area of science, I think.
In all your years, Kevin, of science, of surgery, of research, you're an inventor, you have all these patents, you're one of the most cited scientists in the world right now. With all your success, what would you say has been the key to your success? From a researcher, a doctor, an entrepreneur, an author, what has helped you create abundance in your life? What would you say are those factors?
Having a strong personal philosophy.
What is that philosophy?
That I wanted from a very young age to spend my life working on things through science, making discoveries that would help people. And you're right, I've had the good fortune, the privilege of working on lots of different things. But as you know, when you do that, sometimes things get hard. Sometimes things don't work out. Sometimes it takes 100 experiments to have one that works. Sometimes you have to write 20 drafts of a book to get one that's published. In those times, if you don't have a powerful personal philosophy, a guidepost, a mission, an objective, and a plan to get there, no matter what, then I don't know how people do it without a strong personal philosophy. And I talk about this with sincerity with you because I worry that young people today, you talk about how much anxiety there is. I think a lot of that stems from the fact that young people today are not spending enough time developing a strong personal philosophy. What does life mean to them? What do they want to accomplish in the time that we have here on this earth? Who do they want to help and benefit, and why? And without that, it's just, I can't imagine getting through it. With that, you can do anything.
Yeah. Without a purpose or a vision or a mission or a game plan, even for the next 6 months, you're kind of asking yourself, what am I doing every day? Why is this happening to me? Why am I not getting what I want? When you're not clear what you want, it's hard to go create what you want. What would you say then is one of the hardest things you've ever personally been through in life?
2 deaths.
Really?
Yeah. I mean, the death of my mother.
What you talk about in the book, yeah.
Yeah, when I was 5. She died unexpectedly, very suddenly, of a brain tumor.
She was 29, I think, or in her late 20s? Or?
Late 20s. And my father had me and my brother and sister. Tim was 3.5, and my sister Sharon was an infant.
Wow.
And
you were 5?
When I was 5.
Wow.
My grandfather, my mother's father, was a professor of pediatrics at Yale Medical School. And I remember sitting on his lap and saying, why didn't the surgeon take the tumor out? And he said, well, because it was growing in her brain, and it had almost had like legs that were stuck in different parts of the brain. And if I had pulled the tumor out, it would have damaged multiple areas. I said, well, Grandpa, somebody should do something about that. And he said, maybe you will.
Wow.
And I remember that like it was yesterday. And then the second death that influenced my career was a little girl named Janice. When I was training to be a neurosurgeon at the New York Hospital in the Upper East Side of New York. And Janice had been crawling across the kitchen floor when her grandmother was cooking dinner. And just as Grandma turned to drain a pot of boiling water in the sink, she tripped and spilled all the boiling water on Janice. And it was horrible. It was absolutely horrible. Her face wasn't burned. She had this angelic, beautiful face.
So the rest of her body, her back was burned.
Her whole body, 90%.
11 old.
11 months.
Oh,
so
man.
Her chances statistically of surviving, we knew when we met her, were almost zero. But we started calling her our miracle baby because after almost a month in the hospital, she kept battling back. She was incredibly resilient, and I won't go into all the details, but we got to thinking about sending her. Maybe we'll get to send her home. It would be a miracle. I was standing in the doorway to her room, and she was rocking in the arms of a nurse who was giving her a baby bottle at lunchtime, and Janice's eyes rolled up in her head. I ran in the room. I put her in the crook of my arm. Her heart had stopped. I gave CPR. I gave her mouth to mouth, and called a cardiac arrest. The whole hospital was there in minutes, and the code went on for, it felt like hours, but everything was perfect in the code, and she was gone. So I had to tell her mother, and it was horrible. It was absolutely horrible. I didn't know why she died. Did not know why she died. Couldn't explain it. We all thought there was no reason she should have died.
She was improving, it looked like, right? Or
she was improving, and there was no evidence of infection. But I had to write on the death certificate, cause of death, septic shock, which means some unseen infection had caused her heart to stop. And so pretty much then and there, I decided I'd go in the laboratory and try to understand the inflammation that led to Janice's shock. And that's what I've been doing since 1985.
Wow.
Still working on it.
Still working on it, really? Because there's no, if someone's getting better from something like that, but I guess septic shock can still kill someone, like in a moment?
Septic shock can kill very quickly. It's less lethal now than it was in 1985. We have better ways of treating it. But there's still no clear understanding of who it will affect and when.
Really?
What we know today are the molecules some of the same molecules actually that cause inflammation in rheumatoid arthritis are the molecules that in large amounts, massive amounts, cause septic shock. But it can come on so quickly, we can't always prevent it. In Janice's case, I'm not sure even today we could prevent it, but
really?
I'm pretty sure that the molecule that killed Janice is called TNF, and that's the molecule, one of the molecules now that is the target of the biologic drugs that are used to treat rheumatoid arthritis,
wow,
which is also stopped by vagus nerve stimulation.
Wow. Dr. Tracy, I want to acknowledge you for your personal philosophy and your mission and your purpose over the last 3-4 decades of getting into the field of medicine, neuroscience, and trying to understand how to heal the body and the mind and all these things, how they're all connected, which is a symphony of nerves and cells that we still don't really understand. A lot of it sounds like, but you've committed your personal philosophy and your mission and your purpose to figuring these things out and bringing healing, hope, inspiration, and tools to provide better lives for people. So I want to acknowledge you for everything that you've created up until now. Your new book, The Great Nerve, the new science of the vagus nerve and how to harness its healing reflexes is out. People can pick up a copy. I'm curious, what is your personal philosophy now after all the success you've had, the impact you've had? What is your personal philosophy now, after this book, in the next decade or two, that you're working on?
Collaborate, don't compete. That's number one. I counted recently, I have more than 1,100 co-authors.
Wow.
And co-inventors.
That's pretty cool.
It's a blessing to be able to work with brilliant people and collaborate with brilliant people around the world. This is not I and me in this story that you just summarized. This is us. It's huge numbers of people who, like me, have committed their lives to science and to medicine and to helping other people. And when you work with people like that, you can do anything. Mm-hmm. And the second group that has to be acknowledged are the thousands of patients, millions who are suffering, and the thousands who step up to participate in clinical trials and in clinical research. Because first of all, you acknowledge my colleagues and me and with this praise and these kind words and thank you. However, they're the ones that need the help, and they're the ones that need the acknowledgement, and they're the ones that take the risk. I get to try to do things with my brain and my colleagues and my lab and clinical trials. I enjoy it.
Yeah.
It's my passion. It's my life's work. I love it. They suffer. And they participate and they volunteer and they step up anyway. So if anyone deserves credit in this, it's the teams that do the work and the patients that step up and participate and then advocate.
Yeah, it's a big risk for them. They don't know what's going to happen.
We don't know, and they don't know.
Yeah,
I mean, Albert Einstein said it best. If we knew what it was we were doing, it wouldn't be called research, would it?
Yeah.
So patients step into a research trial, and we honestly say, this is what we think, this is what we hope, this is what we want, but we don't know. And they say, I'm in.
Wow, that's scary. But you have to come from a desperate place, essentially, to say I'm in. Because the pain is so great that you're like, anything that could potentially help this is worth the risk.
And some people who are arguably not, quote unquote, suffering that much, they step in because they want to help other people.
Wow, man, that's powerful. What would you say is the biggest personal challenge you're faced with at this season of life?
I think we're entering an era of anti-science, which is going to be a challenge. The idea somehow that you can do science quickly and for free is on the rise. There's an idea of cutting this and cutting that because we've solved all the problems. I just think you can look back for a minute at the 1920s. The world was coming out of a pandemic that killed tens of millions of people.
Really? Wow.
Tens of millions. Look at the numbers versus the last pandemic. It's orders of magnitude more deaths worldwide. We were on the heels of a massive disinformation campaign in the media because during World War I, news of the pandemic was suppressed by the countries that were fighting in the war because they didn't want the enemy to know that their young, healthy men were dying and cutting into troop supplies. They didn't want the troop numbers known. There was a rise in the United States of eugenics and the sterilization of tens of thousands of women and some children, mostly because of either low IQ, poverty, or the color of their skin, disproportionately women. This was sanctioned by the Supreme Court. And this all culminated in a trial which became known as the Scopes monkey trial, in which a teacher in Tennessee was arrested for teaching evolution. The judge at that trial testified that scientists could not testify because it wasn't a scientific question.
Interesting.
Dozens of other states adopted those laws banning the teaching of evolution in school. This lasted for 10 years. This anti-science, anti-intellectual period lasted for 10 years on the heels of the pandemic. What brought us out of it? Why am I realistically optimistic that we'll come out? 1932, the discovery of sulfanilamide, the first antibiotic that was widely available, was given to Winston Churchill, who was critically ill, perhaps dying of pneumonia. He survived, obviously. and led Great Britain through World War II. Soon after that, penicillin. Blood banking came on board in the 1930s. And during the Coconut Grove fire, a disaster in Boston, the availability of a blood bank saved dozens of lives. This spawned the regionalization of blood banks eventually worldwide. That enabled transplant surgery. So why did we come out of it? Because everybody is going to need a new cure someday. Everybody. You know, the person who's healthy has 10,000 problems. And the person who's sick has one problem. You have a politician's son or daughter or spouse or grandparent or best friend gets a critical illness and we don't have a therapy, all of a sudden science and research are going to look pretty darn important again.
Yeah.
We're in a cultural period now where all the forces seem to be aligned against that. There's a major pushback against doing science that takes years to make the cures that we're using today. Never mind the ones that we're going to use in a couple of years. The cures we're using today were invented 10, 20, 30, 40 years ago. We take them for granted.
Yeah.
We're going to have diseases that continue to injure and disable and kill people. And at some point, the pendulum will swing back. And when that happens, hopefully the United States and the global medical science research infrastructure will have survived this period and come out even stronger.
Yeah, that's powerful. As a neurosurgeon who's done over 1,000 brain and spinal surgeries, what is the number one skill you wish every human being could learn to master to help them improve the quality of their life?
I think be in the present and listen to the person you're talking to. The person you're talking to will always tell you how you can help them if you listen carefully enough.
You think a lot of people are not living in the present?
I think most people are not living in the present. Do you?
I think they're living in stress or overwhelm or like...
But that's not the present.
Exactly. Yeah. Yeah, I know. They're like living in like some type of fight or flight or stress or like
living in either
thinking about the future, what they need to do.
Or remembering some terrible thing from the past. That's not the present.
Yeah.
I mean, yeah. No, it's not easy. You know, I don't think you can go on a website and get a quick fix. I think it requires, once again, a commitment to a personal philosophy to decide what it is you want to do and why you want to do it, and pursue that.
Are you someone that practices meditation or prayer, or what are some of the therapies that you practice that are non-surgical or non-medical related, I guess?
I try
to support you staying in the present.
I think the advice that grandma gave you, and hopefully your primary care physician, you know, eat a balanced diet, get enough rest, exercise regularly, be engaged in your family, community, friend groups, have a hobby, read. These are all critical things, I think, to having balance, homeostasis in your life. I mean, if the vagus nerve is anything, it's a symbol of homeostasis and balance. In addition, I think you can supplement those things with meditation. I do try to meditate every day, once or twice, just 5 or 10 minutes. I do mindfulness meditation or breathing meditation. I try to take a cold immersion several times a week, not because it's relaxing, but because it's a massive stimulus to fight or flight, which is anti-inflammatory. I mean, when you fall in the cold water or switch the shower to full cold and you feel that I gotta get out of here and this hurts and I don't want to do this, that's fight or flight.
And that's a good thing.
High levels of fight or flight, as long as your doctor says you don't have a heart condition, high levels of fight or flight are anti-inflammatory. And then I'm fascinated by the process, because if you stay there, you've done this.
Of course, I did it yesterday. Yeah. It's cool.
What happens? It's like everything slows down.
Yeah.
And you feel almost like you're watching somebody else do it. It still hurts, right?
Painful.
It is. It doesn't stop being painful. But it's a weird place watching. That's parasympathetic. That's vagus nerve. That's when your heart rate slows down. That's anti-inflammatory.
Yeah. And you told me before that you were one of the scientists that studied Wim Hof's, who drew his blood at some point when he was meditating or doing breath work. Is that right? Like 15 years ago?
Yeah,
Before he was Wim Hof, before anyone knew who he was.
Back a long time ago, like 2010, he visited the lab. I had met with His Holiness the Dalai Lama up at Phoenicia, New York. He has a property there on top of a mountain, and it was a meeting that the Dalai Lama had hosted of scientists and researchers, and so through the Dalai Lama's network at Menla House in New York, they introduced me to. They said, "We really want you to meet this guy Wim Hof." I said, "Fine, bring him to the lab." So he came, and the lab I run with my colleague Sangeeta Shivan. Sangeeta and I run the lab together, and we said, "Well, what are we going to do?" We had to get an IRB protocol, which is institutional review board, a human subjects protocol. They did that for us on an emergency basis, and we decided we would study Wim Hof's immune response after he did his whatever Wim
Breathing
Hof does.
techniques. Yeah,
Well, we didn't know.
Yeah, you're like,
all we knew
all
was
right.
like he says he can control his immune system. That's all we knew.
This is 15 years ago. That's probably,
This is not now. Now when everybody knows.
Yeah.
So he went and we brought him into our clinical facility, and we drew his blood, and then we shut the door. He said, "Okay, do your thing," and we went and got a cup of coffee, and we came back like 2 or 3 hours later, and drew his blood again, and he said, "What happened?" I said, "We have to analyze your blood. Come back in a week." So
He's like, "Tell me now." Yeah, he's crazy.
Tell me now.
Yeah.
So he comes back in a week, and he goes, and we said, "What did you do when we left you?" He said, "I breathed like a mother."
Yeah, it sounds like him.
So he said, "Why?" And I said, "Because you lowered your inflammatory response, which we measure through a very specialized assay in our lab. You lowered your inflammatory response by like 75%. He goes, "Are you going to publish me?" I said, I'd love to, but I can't publish you." He said, "Why?" I said, "I can't publish. You're an N of 1. I have to do, Sangeeta and I have to do a proper study."
With like 100 people at least or something, or maybe a year.
We said 20. We
Yeah.
said get 20 people, teach 10 of them your breathing method, and then 10 of them not, and then switch the groups and do all the tests and see what happens. And
Did you guys do that?
so he said, "What would that cost?" And I said, "Oh, probably $750,000, something like that. It's expensive to do these things." And he said, "Well," I said, he was there with a group of businessmen. I said, and they said, "We'll get back to you." Well, they didn't get back to me, but that's okay, because a couple years later, I was reading the scientific journals, and I saw an article from my colleague in Amsterdam, Peter Pickers, who runs a big research lab.
He did it.
He did the study.
In Amsterdam. There you go.
Not Amsterdam, in Holland, but in a different city. I forget which city. And he did the exact study with 10 people, and the 10 people that breathed lowered their inflammatory response.
What's that mean? They lowered their inflammatory response.
So what we did was we took the white blood cells we took the whole tube of blood that has white blood cells, and we added an activator that makes the white blood cells inflame to make lots of cytokines. Cytokine storm in a test tube. TNF, IL-1, IL-6.
So you almost inject it with like...
The tube, the blood tube.
Yeah, the tube.
So we didn't have to inject
Sure.
him. We just injected his white blood cells.
With like a
toxin.
a virus, a toxin.
A bacterial toxin called endotoxin, lipopolysaccharide. And the results were remarkable. In the subjects that breathed, they lowered their cytokine release in the blood by 75%.
Meaning they were more resistant to getting an infection or...
They were more resistant to having a damaging amount of inflammation. So inflammation in small amounts for the right period of time is good for you.
Yeah, you sprain an ankle, you want to have a little inflammation.
You need
right?
inflammation to heal the ankle sprain. You need inflammation to fight off the infection in your finger or your arm. You need some inflammation. People with no inflammation, because they're immunosuppressed, they can have serious complications. You want inflammation. Inflammation is not all bad. It's all bad when it's excessive. So the Wim Hof breathing gave a reduction of inflammation. Why? That's the next question. Well, it turns out in Peter Picker's study, where they injected the endotoxin into the people, not into the...
Oh my gosh.
So the people that got injected got fairly sick. The people that breathed first got much less sick, much less headache, much less nausea, much less fever. And Peter measured hormones in the blood of those people and found that there was a massive fight or flight response. So breathing in the Wim Hof method, it's breath holding. It's like a, is it called tantric
Yeah,
yoga
it's like a
breathing?
system. It's like you try to do it for like a minute or two, deep breaths in and out intensely, and then you breathe all the way out and you hold at the end. And I've done this many times where I've held for 2.5, 3 minutes a couple times with no breath in my lungs. So I guess you're oxygenating the blood and you're...
What you're doing is, I've done it too, and I've gotten up to 3.5 minutes also.
Yeah.
But it's what's weird is at 3.5 minutes, you're still not really sure you really need to breathe.
Yeah,
It's
you're
not
just
like-
sitting there, you're vibrating, your whole body's
Yeah.
vibrating, you're just no air in your lungs.
But what you do have at that point is you have very high carbon dioxide levels.
And what does that do to the nervous system or to the vagus nerve?
Well,
or immune
the
system?
carbon dioxide, the rise in carbon dioxide is what's screaming at your brain to breathe. It's not the fall in oxygen, it's the rise in carbon dioxide. And as carbon dioxide rises, it also increases the ability of your hemoglobin to carry oxygen more efficiently. But that wasn't the main effect on the immune system. It was, in fact, the fight or flight response. So with the massive urge to breathe, with the accumulation of carbon dioxide, that horrible feeling you get, the shaking, that's catecholamines. That's epinephrine and norepinephrine from fight or flight. That massive amounts, we talked about it before, massive amounts of fight or flight turn off inflammation. That's one of, that experiment in Wim Hof breathing people was one of the proofs of it. Another one, my colleagues and I in New York years ago, we infused those hormones in volunteers, in sailors and Marines on shore leave. And we infused them with those hormones, epinephrine, norepinephrine, and even cortisol.
And
then we injected them with endotoxin to make them sick. And the ones that got infused first were less sick.
interesting.
Yeah.
Wow.
So I think Wim Hof breathing, which, by the way, you did it on a couch. I saw your podcast or your YouTube. I did it. I do it not every week, but every few weeks I do it after a workout. I lie on my gym floor. You shouldn't do it in a pool. You shouldn't do it driving a car. You shouldn't do it doing anything dangerous.
Don't
and
do
if
it
you
in
have
the
any
ice.
condition, you
Yeah.
should check with your doctor and do it with a colleague.
Or do it minimal, you don't have to push yourself that far. But so you still do it today every now and then.
Oh, absolutely.
Yeah. And you see the benefits, you know the benefits.
I don't know the benefits. I like the way it makes me feel.
Yeah.
I mean, Mr. Hoff says it's a great time after you do that to do an extra 10 or 20 push-ups.
Yeah, I've done it.
I have too. It's
You're
weird.
yeah, it's crazy. You have more push-up strength. It's crazy.
It is very.
He had me do push-ups first and then do the breathing and then do push-ups after with no air in my lungs.
And you could do more.
Do more.
Yeah.
Isn't that
weird.
interesting?
Yeah, it's very interesting.
So you could breathe and do as many as you can, then stop, then do the breath work for 3 minutes, and then blow all the air out of your lungs, hold it, and then do push-ups. You can do more.
I mean, you talk about a personal philosophy and a guy who's compassionate and really wants the world to be better. That's
He
him.
is. Yeah, he's
You
great.
know, he. I remember after I told him I couldn't publish them, he said, "What should?" And I said, "I did say if you do this experiment with the 10 or 20 people and publish it, you'll make the world a better place." And he's repeated that story on several other podcasts around.
cool. That's
and
cool.
it makes me feel good.
That's good.
It is good.
That's amazing. Dr. Tracy, I appreciate you being here. I have 2 final questions for you. This is called the 3 truths. So imagine it's your last day on earth many years away. You get to live as long as you want. But for whatever reason, all of your written work, your publication, your scientific research, for whatever reason, we don't have access to it anymore. But on your last day, you get to leave behind 3 things you know to be true, whether it's from your personal experience in life, your personal philosophy, your lessons, anything you can think of, what would be those 3 lessons you would share with the world?
Yeah, you find love and true meaning and joy in your family every day. That would be number 1.
Wow.
Number 2 is a single person working diligently for a lifetime can change the world. And we all have the opportunity to do that. That's the second truism. And number 3 is probably related to that, but human beings, people, don't have any problem accomplishing their goals. They have problems, but any goal can be accomplished. The hardest thing for a person to do is to pick the goal.
Mm-hmm.
If everybody knew that and spent more time picking their goals, the world would be a better place.
Dr. Kevin Tracy, The Great Nerve. Make sure you guys get a copy of this book if you want to learn how to optimize your health and learn how to harness its healing reflexes of the vagus nerve. Final question for you. What's your definition of greatness?
Leaving the world better than you found it.
Kevin, thanks for being here. I appreciate it.
Thanks for having me. I really
you so
appreciate
much.
being here.
Amazing.
We think something's a problem, and it could be, but we can find the answer. But if we get stuck in that loop, we get all confused and chaotic, and then the anxiety builds, and then it starts distorting.
Yeah.
So then the anxiety flips, and then everything in your body, all the stress response which goes with anxiety, which is supposed to make you alert, now makes you confused. So too much